you'll see a number of exam questions where they ask us to work out the temperature at which a reaction becomes feasible. Put a little diagram here. So if delta G is positive, then the reaction is not feasible, and then once delta G becomes negative, then the reaction is feasible. So really the turning point is where delta G is 0. So if we let delta G be 0, then this allows us to rearrange the equation to work out temperature as long as we know the enthalpy change and the entropy change. So T delta S is going to be equal to delta H for delta G to be 0, and then the temperature will be the enthalpy change divided by the entropy change. And then there's one thing that we just need to be careful about again, and that's the units. So remember, delta S is going to be in joules, so we need to convert them to be in the same units, and probably what we want to do is divide delta S by 1,000. So if you look back a couple of pages in the notes, we'll find those values for the thermal decomposition of zinc carbonate. So the enthalpy was plus 71 and the entropy was plus 175.2, and you can see there dividing that by 1,000, and I'm getting 405. Remember, the units are in Kelvin. Worth checking the temperature. Obviously you won't know the answer outright, but it's got to be positive, so Kelvin values will always be positive. And if you get a very, very small number, and by very small mean 1 or 2, then this is unlikely to be the right answer. Probably what you've forgotten to do is divide by 1,000. So expect an answer probably in the hundreds, even thousands. So 405 Kelvin is roughly 130 degrees centigrade, so just a fairly cool oven at home. So it's saying that 130-ish degrees C, then zinc carbonate will start to decompose.